So we're in week 5, almost week 6, but we're talking about ignition. And again, this class about combustion control. So I'll talk about ignitions, how to adjust them, how you know if the igniter is working or not. Then I'll show you a video about primary control. Hopefully by now, I think by now everybody seems very comfortable with primary control. I've seen people wiring boiler yesterday. Everybody was comfortable. Everybody knew what are the components. That is very, very nice. And I feel like everybody is comfortable working with equipment because you know all the components. You know motor, you know the valve, you know the primary. So we'll keep doing that. We'll do that one more time. We'll do another wiring. Then we'll do some troubleshooting where we have something wrong with the boiler and you have to go and try to fix it. Again, knowing the components will help you try to troubleshoot it. So ignition system, we've seen these before. What are the purpose of the igniters here? They produce a spark. Actually, luckily I have an igniter here. We've seen it before. So you always want to go with the alligator clips because they enable you to plug in. So you can take out your igniter from the primary and you connect one to the hot, one to neutral. Did you notice something yesterday? Some igniters they don't have colors.
Yeah.
They're gonna be both black.
Yeah.
This happens. That's especially for old models. Now they try to color code. So if you have two black wires, where are they gonna go?
Doesn't matter, neutral and hot.
Neutral. Doesn't matter which one. But one of them gonna be neutral. One of them going to be hot. I had some students who wired both of them to hot. What would that do? It's going to burn your. It's like seeing smoke. Why? If you put both in hot, how much voltage you're getting into the transformer? Hot and hot. How much power is in hot? 110. So if you get 110 and 110, that's 220. You're going to fry your igniter. Same thing for older motors. Probably they will come in two colors. And back then they just expected everybody to know that there has to be a neutral. So now they're trying to make it more user-friendly, I guess. So you test your igniter, you plug it by itself, take it out from the control, and it should work. And you can see the ignition here. So if you look closely, you'll see a very nice blue spark, 10,000 volts. And it's sometimes helpful to take it out of the burner and look at it. Because you want to see that it's not touching the plate. What happens if it touches the plate? It's going to arc and it's not going to give you the temperature. So you want to be consistent, like so, and very clear. Okay, is this a transformer or an igniter? It's an igniter. It's lightweight, it's electronic. So they call them electronic igniters. Transformer is the big one, big, bulky, heavy one. The terminology changes from one field to another, but this is an electronic igniter. And it has the data on it, 120 volts. The output is 14,000 volts, which is a lot, yeah.
So if you were wiring it and had a transformer, you'd wire it like you would wire it.
Yeah, they're the same. They're the same size. I mean, the transformer is a little bit bigger, but this is lightweight. They were very popular for a while, but a lot of companies switched back to transformers because they are more reliable. These things have advantages and disadvantages, and we talked about that. The advantages is either they work full capacity or they don't, which is good. Either on or off. However, they break faster. Transformers are more reliable, but sometimes they'll give you a weak signal, which is frustrating. So they'll give you a spark, but not enough spark. So that's our igniter. A lot of issues with delayed ignition is caused because of the igniter. Not enough spark, not in the right location. And we talked about the spray angle. If you put it a little bit too far, a little bit too close, it might not ignite. So if you have delayed ignition, if you have smoke, if you have no ignition, the first thing you do after you check that there's oil in the burner is to check the igniters, make sure they're in the right location. and because they also do wear out. Same thing with your spark plugs. After a while, 60,000 miles, you have to change because with this arc happening between the two ends, it will eventually wears out and do not provide with the right ignition. Also, did you notice that there is certain location has to be snug inside the neck here, the extension, and it's really easy to remove. If they're wobbly, that's not a good thing. You want to be steady. So the ceramics could be broken or old or cracked. Sometimes you might have back flame, but it's not the right distance from the flame, so they get overheated, and by doing so, they will start to crack the ceramics. You loosen your igniter from the side, and sometimes if they're short enough, you can pull them to the top. If it's too long, you have to take out the burner and pull them out. The transformer is usually supposed to be at the top, and in some models like Rielos or V-Spins, they have different kind of controls. They're very small and they're included with the primary. So you see the primary and the control all together in one component. It will look something like this, and the small control will have its own transformer. So make sure you just identify where are the components. So this is one of the questions that's gonna come for sure in the oil burning exam. They will ask you about two things. Are we done with this? We're good? So this is kind of confusing. The first thing is called the interrupted ignition, which means the ignition comes in until the flame is on, then it goes off. That's interrupted ignition. And there is a second thing, which is intermittent ignition, which, if you think about it, it also means it will stop, right? It's not continuous, but for some reason, it also means continuous. So the spark will continue to light up through the entire cycle. So that was the practice for a long, long time, and now it's not the code anymore. However, if you have a burner that is old, it probably has been grandfathered in, and you can continue to have that. So for this, there's different control, and probably you'll have 3-wire that control. This one here. So this is the old primary control, and there's only one wire that powers everything. This powers the motor, this powers the transformer, and the oil valve, which means that the ignition is on the entire time. It's good for old boilers because if you have ignition the whole time, you have constant source of heat to ignite the oil. However, it's not a good thing because it will cover up a lot of issues with the smoke and also with waste energy. The igniter consumes around 75 watts, which is a lot. Huh? Again? If the spark is continuous, doing all the time, that will consume energy. So let's focus on this a little bit. So interrupted ignition is the current code where you have to cut off the ignition once you prove the flame. How do you prove the flame? Cat cell. The cat cell sees the light, it will know there's flame, it will cut off the ignition. And probably you've seen it in light bulbs, right? So we'll cover the cat cell. Once we have the oil valve on, we let go, and it sees the light until cut off. Within 15 seconds, it will cut off the ignition. So that's called interrupted ignition, which is the code. Intermittent ignition is when it's continuous. So just, yeah, that's continuous. Everybody got that?
I just have a question. So
Yeah.
intermittent ignition, the spark remains as long as the burner's running?
Yeah.
So when it's not running, there's no spark?
Yeah.
So when you fire up the burner, there's a spark,
Yeah.
and the spark just stays on
Yep.
the whole time?
Remember the pilot? We used to have pilots that's on all the time when we used to have gas stoves, and you looked underneath the stove, there's small gas burning the entire time. That's not the code anymore again because it's very dangerous. And sometimes the wind comes into the kitchen and blows out the pilot, and you start smelling gas. So that's very, very impractical. It has been replaced by the spark. So now, again, they don't want something that's on all the time, because in case there's a leak, there's a problem, you don't want to have a constant source of ignition inside the chamber. Transformers, we talked about that. Transformers, they either step up the electricity, the voltage, or step it down. We step it up to 10,000 volts. In this case here is 14,000 volts, so that's a lot of volts coming in. You don't have to worry about the calculation here, but what you want to know is what is the primary and what is the secondary. The primary is the input. So what you put in is the primary. Secondary is what you put out of it. Is it reversible?
Yeah.
Not always. Not always. So do not assume that you can put 24 volts and get 120 volts. So if you have 120 and it gives you 24, that's how it was designed. Probably there's a diode or something that prevents the flow from coming back. So putting 24 volts is not going to give you necessarily 120 volts. In theory it will, but in the equipment you should stick with the input and output. So it's very important to know where's your input and where's your output. Many times it does happen when you wire a control board, especially for the TACO or other small controls. People will plug in the power into the 24 volts, and that will burn out your volts. It works with induction, again, and it's heavy. It's insulated with tar. It's not impervious to water or overheating. So if you touch a transformer and it's very warm, it shouldn't be too hot for the touch. If it's too warm, something is wrong with it. It has to be replaced. Most of this equipment designed to be in the outside. It should not be too warm for the touch. You can touch it. That's okay. It should be warm but not hot. So is the motor. The motor is too hot. Something is wrong with it. Probably friction. Probably some of the winding is bad. Let me see if I have one of the transformer. So that's, this is a Riello primary control. As you can see, it has both the electronic ignition and the control, everything included, and terminals in here. So probably it functions the same way as the primary cat control and the ignition combined. And it's only specific for one model, so every model has its own primary. This is a transformer. Again, it has two sides, and you gotta know which one is the primary and which one is the secondary, and you have to know whether they're interchangeable or not. Again, the winding is protected by tar, should not be overheated, and should not be exposed to the outside. It has electromagnetism, so we are inducing the current, inducing a magnet to this iron core. That's why we have an iron core here. Look at these slates in here. These are steel plates. We have winding inside, so this is the same thing happening here. This is my iron core, and this is my winding this side and this side. So we're inducing magnet into the core. It transforms 120 volts into 10,000 volts, which is a lot. And that's the minimum for the minimum voltage required for a transformer. You can have more, but any less, and probably you'll have weak ignition. What color is it supposed to be in theory? Blue. If it's orange, that means it's a little bit weak. It's not going to give you enough.
But the igniters?
Yeah. You see this one, it was blue and a purplish. If it's orange or yellow, it means it's not hot enough to ignite.
Can it be that color?
Huh? Yeah. If you push them further, it's going to be orange. Electronic transformers usually between 14,000, 140 is 14, not 140. 14,000 and 20,000. They're also called solid state. So how do you test these transformers? There's still a lot of gizmos that you can test them with, but usually they either work or don't.
Isn't there that thing you can plug it into?
not for the igniters. That's for the transformers. So these things are either they're on or they're not. If they're not working, they will be dead. So just replace them. Same thing with your phone charger, your USB. There's nothing you can do with it. Either it works or it doesn't. And sometimes it's even more frustrating. It shorts a little bit and it cuts off. Something's wrong with those wires.
Can you use the screwdriver, or was that the?
No, you can't. You can't use a screwdriver with the igniter. You will burn it. So do not use the screwdriver method with this. You do not use any of the other methods used for the transformer with the igniter.
So then how do you check it?
We just said either it's on or off. It's on, it's giving you sparking, good. If not, it's not functioning. The only thing you might be able to check is the wiring condition. You look at the wiring condition, make sure it's on. You're not supposed to open it. If the wires are okay, they're connected, it should work. If it doesn't, change the igniter. So which is better? To have continuous spark or intermittent spark. So if we have the ignition on the entire time, it will definitely use the electrode's life. Again, with continuous spark, it will wear out. Probably within 6 months, they will get shorter. You understand?
I said it will consume too much energy.
It will consume too much energy, and it will also wear out the electrodes. The tips will get shorter and shorter, and eventually it will be further. And if it's
Then it'll
further,
turn yellow.
yes.
Wait, what's the you know how you like when you do the electrodes, it has to be specific. What is it, 1/8, right?
Yeah. If they are shorter, they're not going to be 1/8. They're going to be bigger. Electricity will be consumed. You will have at least a light bulb power going through it the entire time, so that's eventually will add up to a lot of cost for running the igniters. Operational noise is increased dramatically. You heard the buzzing. It's going to be on the whole time, which will add to the noise. It is actually noticeable. You can notice the noise going on the entire time. Intermittent ignition may hide combustion problem that could cause soot and plug boilers. So if you are burning, whether rich or lean, or you have a lot of smoke, you're still going to run, even though it's not with fire, and that will lead you to not know about this problem. Eventually, it will clog your chimney, and you need to have the boiler serviced. So it causes a lot of problems, and you don't know if you're getting good combustion or not. And again, it will add to your cost of fuel operation. NOx, nitrogen oxide. Nitrogen oxide happens when you have too much flame, that burning at the wrong temperature, and it will be much higher if you have constant ignition. That's why they stopped using continuous ignition. Even though it makes the fire surely to happen, it's better to have interrupted ignition. And Massachusetts is a low NOx state, so they try to make flame and fire without producing a lot of nitrogen oxide. Nitrogen oxide is not good for the environment, so we try to reduce most of it. And if we have bad combustion, probably we will have nitrogen oxide. So this is one of the reasons that you don't want to have intermittent ignition. Transformer, so they look like secondary and primary. And this is the target we're trying to achieve. We're trying to jump the spark from one end to another. They are tower insulated, so they can possibly melt, and if they melt, they are not going to give you the right temperature. So when you install a transformer, make sure it's not in a hot place. How would that happen? Somebody install a dryer next to the burner, and the dryer outlet is close to the igniter. It will over time get hot, and again, the tar inside will melt or ooze outside, and that will not be good because wires inside is supposed to work individually, not as a bucket. Are they designed to work outside, outdoors? No, they're not designed to be working outdoors. Moisture is a big enemy for tar. Why? No. What does moisture do to the igniter? What does moisture invite?
Bacteria.
Bacteria. Bacteria will grow, and eventually it will eat your tar. And if you eat it, it will. and you'll have a lot of oozing coming from the transformer, and eventually it will stop working. Transformers are a little bit more expensive than igniters, and that's why you want to make sure they are functioning properly. If not, you go to change to make sure they're really working. They have high electric consumption up to 100 watt, 75, 100 watts. So they do consume a lot of energy. That's why it's better to have them ignite and stop. They degrade over time. That's a fact. Over time, the transformer will lose power, and that's because the insulation inside is wearing out over time with the heat. So they take a long time to degrade. The average lifespan is around 10 years, which is very decent. How do you test a transformer? We had a lab, if you remember, about testing a transformer. Does anybody remember what was some of the tests? One of them?
Putting the things on what are the standing things called?
Electrodes.
Yeah.
So you can get the electrodes closer and look at the spark color. And one of the best ways to test a transformer is to turn it on and put an ammeter in one of the leads and see if the amperage draw stops. A lot of issues that happen with the ignition is it will be okay for the first minute, then after 5 minutes it will start to drop, and that means it's not going to operate very well once it's warm up. Why? What happens to the conductivity when the temperature increases? If you increase the temperature, does the conductivity decrease or increase? Decrease. So hot wire in the summertime, you're probably going to have issues with the internet because the wiring is not conducting the way it's supposed to. Jack, are you okay? Use a tester. This is the big tester you can put on the leads and make sure how much voltage do you put on it.
The tester is an electrode tester, or?
Yeah, this is no, it will test the output here because we want to see how much voltage you're getting. Can you use a multimeter?
No, I thought you said an amp meter.
No, the ammeter is when you turn it on and clip it on one of those leads and watch for the amp to drop.
Okay.
If it stays constant in 5 minutes, that's good. If you want to test the voltage here, you need a special tool, transformer. Never put this into your transformer, it will get fried and probably get zapped. What is the limit on the multimeter? 600 volts. It should say on it in the front. What is the limit? You can test the resistance between each lead and compare them to each other. They should be within 10% plus or minus. And you can test the transformer winding. Which one do you think is going to be higher resistance, the primary or the secondary? Why? Secondary. High voltage, high resistance, high coil, big coil. Doing a lot of resistance, around 12,000 ohms. The primary is 120, so it's going to be smaller, less winding, less resistance. So between 3 ohms and 1200 ohms. Solid states, they're not really easy to diagnose. Either they work or they don't, so we just replace them. They are heat resistance. They have resistance to moisture. Low power consumption from 30 to 50 watts. So that's almost fraction, half or third of a transformer. Again, this is another method. Compare the resistance between each lead with the ground. And again, 10% is acceptable as a difference between the voltage. We did that lab last semester where we tested a transformer. If you ever forget and you want to test a transformer, you can go back to the PowerPoint, or actually you can YouTube how to test a transformer. And the best way actually is to contact the manufacturer or look at the manual, or sometimes check the model number. But these are ways to measure to see if the transformer is running or not. This is another way, but I don't find it very effective because the color can change, and even though you're getting the right, you can watch for the color. You can still be orange, but you're still getting 10,000. So it's not really that accurate, and it's really hard to get those prongs to be next to each other by half an inch. So it's really tough. But if you can, put a multimeter, ammeter on one of the leads and test. Turn it on and leave it on for like 5-10 minutes and make sure it does not drop. Usually if it will drop, it will drop after 3 minutes. You'll see the amperage start to drop. If something is drawing less amperage, that means it's not working properly. It means it's not giving you enough power. If the motor is drawing less amperage than it's supposed to, it's not working properly. If it's drawing more amperage, that means what? It's overloaded. So again, it's not good. One more way. This is the ammeter one, where you put the clamp-on meter, a meter for the draw spark. Okay. Cables, bus bars, and spring clips. A lot of incidents happen when you don't touch. Let me unplug this one and show you. I hope you remember some of this information because it will help you know if you are getting good ignition or not. Sometimes you'll test a transformer from the outside, then you put it back in, and the springs here are not touching the bus bars. These are the bus bars here. Those bars are called the bus bars, and they should have good contacts. And if you notice, they make it a little bit springy, so you can have a solid touch. And if it's not touching properly, it will arc. If you have an arc in here, probably you have low voltage in here. So again, if this is a transformer by itself, fine, it's okay. You're happy with it. When you put it back and you're not getting 10,000 in here, it's not igniting. So make sure the bus bars are touching. These are the electrodes. Electrodes are made out of steel, and there's a lot of covering made out of porcelain or ceramics. If it's cracked, you gotta change it because again, they're supposed to insulate the voltage from coming into the casing. Because if you look here, this is all metallic. If you're touching any of that with electrodes, probably it will leak some voltage to the outside. So be careful that it's not touching anything else. And if we, again, look at the electrodes from the inside, yeah, we can have one over here. But you've seen it. So if we look on the inside here, you see the electrode, they are held by a metallic frame. So you want something that's going to be heat resistant and also an insulator. Ceramics are the best thing we can use for these electrodes. You can't use rubbers, you can't use wood because again we are subjected to a lot of fuel and heat, so it's not good practice. So make sure that it is sound, and a lot of issues will happen with the ceramic if the ceramic is cracked or broken. So some of them have cracks, but not broken completely or not missing pieces. With industrial boilers, it's the issue is more significant. You want to trace the power, make sure you get 10,000 coming all the way from the transformer to the electrodes. Otherwise, you're not going to have sufficient ignition. This is an old way to test for leaks. I've seen this before, but I never used it, and I highly doubt you will need to use this sensor to sense if there's any leak from the porcelain. And if you notice, those leads are very long. Probably they're a little bit expensive, so you want to test if they are leaking or not. But they're not that expensive, so it's better to just change the electrodes if you're in doubt that they are cracked. What do you think will crack for ceramics?
Shock.
Shock?
Move around.
Yeah.
Mess up the 180.
Vibration. Over time, they are very rigid and brittle, so the vibration from the motor could cause them to crack over time. What about back heat? If they get overheated, ceramic can handle the heat, but heat and this to vibration, or maybe you over tighten them, that could cause them to crack, or if somebody drop them, huh? That could be an issue as well. Everything is great with time. The gaps. So the gap here is specific to each burner, it should be according to manufacturer. When in doubt, if there is no guide, we're gonna use 1/8 of an inch is the general rule for using this gap. And the gap has to be the right distance from the nozzle. You don't want it to arc to the nozzle, because again, any arcing happening before those tip meet will reduce the voltage coming into the electrodes. So you want to have clean electrodes, make sure the tips are matching. If one of them is worn out, you gotta replace both of them. Check the connections and check the insulation getting all the way to the electrodes. It's one of the most frustrating issues because, again, so many things can go wrong. You know, we keep trying to fix those issues. So this is what happens. You go for heat, water turns on, and there is no flame, and the system goes in safety. So the first thing you have to make sure it's not happening is that the voltage is getting completely into the electrodes. So if you see, you can be missing some connection here. This could be dry. These could be misaligned. One of them is shorter than the other. So it will take you some time to just try to see why you have no ignition. Especially if your pump is at the right pressure and you change the nozzle, you have spray angle, but it's not igniting. So ignition can be very frustrating, and especially if the ignition comes in then goes up. And if you notice the ignition stays in for a little bit, at least like 10-15 seconds, then goes out, make sure the fire is hot. Once the oil is hot and the temperature is warm, probably less ignition is needed. The most frustrating part is when you start the burner from cold. You agree? It's cold, the chamber is cold, system is stagnant for a while, so the first time to turn it on is the most frustrating part when things are still not like optimal temperature. So, these are the things we have to check, that we have 110 volts in here. If you don't have 110 volts, you're not going to have 10,000 over here. It's going to be much less. Check the primary coil. We're not going to check anything from the inside, but these are the components. Secondary coil, you need to check that. Also check the metallic cover is not dented. There's no leaks. Could leak some solvent. There's some kind of solution inside. Not solution, kind of a paste. They seal the whole thing with paste and they cover it. If it leaks some of this paste, probably something is wrong with the transformer. The mounting, again, this is something a lot of people neglect. Make sure the mounting is sound and it sits completely where it's supposed to. It's not wedged sideways. Over time, these things get open and closed many times, and eventually they do not close properly. And they do not close properly, probably they're not touching electrodes, and that will have you have less voltage at the output. Metal cover, mounting, output, that's something you can change with high voltage tester. The rods. Again, if you replace the rods, make sure they are the right distance. Even half an inch can make a big difference. Here is some troubleshooting charts, and that will help you know what is the problem. I'll show it you in the book. So this issue is called delayed ignition. What happened with delayed ignition? The first time will come in. How many times does the primary try to start the fire before it goes in lockout? 3 times. Excellent. So 3 times. It will try the first time and then stops. Then restart again and try. 3rd time it will just go in lockout because something is wrong. And again, the first time when you start the boiler is the hardest one because everything is cold. It's not at operating temperature. So, we'll start from the last one here. Hold on. Delayed ignition. Start the burner and use test meter to measure the voltage coming into the transformer. Do you have 120? Yes or no? You have 120, let's say it's yes. When the burner is off, attach the leads to transformer tester to the secondary terminal and start the burner. It should be around 10,000 volts. So this is assuming you have a tester with you. You're gonna put the tester and make sure you have 10,000 volts. If you don't have a tester, you're gonna do the other thing. Test the resistance, test for colors. This step is just to know that you have 10,000 coming out of the transformer. So we have 120 coming in, 10,000 coming in. Yes or no? Yes. Move on to the next step. Check the transformer secondary porcelain brush. So check for the porcelain. So we start to move on from outside to inside. 110, 10,000. Let's check the porcelain. Make sure there's no cracks. Check the bushing that is putting in the right place. Check for arc tracks. What are arc tracks? It's a small little crack that you will see on the porcelain. If this is the porcelain, for example, you'll see small cracks. These are arc tracks. They're not cracks. They are not missing pieces. It's just small kind of vein looking like tracks on the porcelain. You see that, some kind of spark went through it at some point, and that will reduce its conductivity, our insulation properties. Yes or no? There's no track, there's nothing. You move on. With the transformer in the closed position, the spring terminals make good connection with the bus bars. So we check the electrodes, they're sound, they're clean. Let's check the second thing. Are these connections sound? You can check that visually. So for here, if you look at this, they're not really touching very well. And they make those little probes here springy so you can touch them at some point, and they give you some kind of margin of error around ½ an inch. You can adjust them, and that's why they put usually springs in here instead of just solid rods, so you can have some kind of margin of error. If they're connected properly, when the transformer is closed position, do the springs terminal make good positive contact with the electrodes rods? Yes or no? Yes. Check the electrodes porcelain. Again, is there any shorts? Is it completely in the middle? Yes or no? Just say everything is good, still not working. What are you going to do? Check the electrodes, even though they are in there and installed already, that they are the specification. Maybe somebody changed them at some point and they did not have that specification, and that's why they're not working. Check the dimension. That's the distance from the nozzle tips to the diffuser plate and to the nozzle. Yes? If all this fails, cool. Change the energy. One of these will work at the end. Okay, we have 15 minutes. I want to show you a video about primary control. We have 2 videos about primary control. I'll show you one today and one on Thursday. And hopefully all the information will come to you as whole. But if no, take some notes of it. Okay?